Hey guys, we're going to talk today about the natural base E. E is the number 2.718. How do we get that number? Is we're going to look at a population of wolves. Wolves are constantly growing in population. So let's say there's 2 wolves today, 4 wolves in a couple weeks, and then it becomes 8, and then 16, and so on and so forth. This is going to grow, okay? But eventually there's going to be a cap of how much wolves this population can hold. This growth cap and rate can be found from the equation 1 plus 1 over n to the n power, which means that 100% of our population moves on, plus our rate of growth. So for us, this example would be 2, and it happens every single time. Well, if we were to continue this growth pattern over 1 to infinity, to the infinity, we would get 1 plus infinity to the infinity power. This is the answer 2.1718. This number keeps going on for forever. However, this growth, the natural growth of human life, means that for every 2 people, they need to create 2.7 more people for our population to grow. So this number is our natural growth. What makes this different than log is that this creates a continuous motion versus kind of a chunky every time that we're looking at a data point. This has some fluidity to it. Okay, to give an example of where base E is super useful is with money. So if we look at our compound interest equation, this says how much money we want at the end, so the amount we want at the end is equal to our principal. So that means how much money we're going to put in times 1 plus our rate over time. So our equation is A equals P times 1 times R to the T. Our rate is a decimal, so let's say our bank account has a 5% interest on it. We would say A is equal to P times 1 plus 0.05 times T. So let's say that we wanted to put in $100 and we want to put it in there for 7 years. It would look like this, okay? Well, what if our compound interest happened not once a year, but once a month? We would change our equation to rate over number of times a year times number of times a year times time. So their same example of $100 at an interest rate of 5%, and it compounds 12 times a year because of the 12 months. 12, and we were doing it for 7 years. We would plug this into our calculator, and that would tell us the final amount of money we would make over 7 years. Continuous, though, is the equation of principal is equal to, is our end amount times our principal times this letter E times our rate times time. Because there's no need for 12 months or once a week or whatever, we're using E for our natural growth over time. So we would put our $100 E times 5% times 7. So this is changing every day, every second, every millisecond. This E is going to calculate this natural growth for us so that we don't have to say on the first of every month, that's when our interest grows. This says it's growing all the time. And it's unrealistic for us to say when our interest grows, so we're just going to say all the time. So we would use this equation if we knew they only counted interest at the first of the month, and we would use this equation if we had no idea when they applied